reaction of alkynes. So this is similar to that of reaction of alkenes, wherein the double bond or the triple bond is the site of reaction. Okay, so this is also an addition reaction wherein the molecules from the other reactants like hydrogen halides and halogens are being added to the triple bond. However, ang difference is we need two molecules of those reactants, of those other reactants, to be added to the triple bond. Okay, and unlike the reactions for alkenes, wherein we only need one molecule. Okay, so the mechanism for the reactions of alkynes, originally you have the triple bond that will be broken first in to become single bond, to become double bond, and then further reaction will break that double bond to become single bond. Okay, so how are these reactions? So hydrogenation. Hydrogenation is a reaction with hydrogen with the presence of catalyst nickel. So for the first reaction, the alkyne will become an alkene, wherein the triple bond will be broken to become double bond. And then from there, from the triple bond, originally, okay, so mabre-break yan. If one bond will be broken, okay, it could now then accommodate, sorry, it could now then accommodate the addition of other molecule such as hydrogen. Okay. However, that would still be an alkene. So a further reaction will be needed. So another molecule of hydrogen will be added with the presence of the nickel as a catalyst, such that that double bond will then be broken. So that one will be broken, and with that broken bond, it could now accommodate another addition of hydrogen. That's why it will then become an alkene. Okay, so the mechanism for this reaction is mabre-break yung double bond, mabre-break yung triple bond, magiging double bond. So it could now accommodate. So here, if it is CH originally, okay, with the triple bond being broken, it could now accommodate the hydrogen molecule. So that one will be added. So this one will become CH2, and that C will then become CH kasi na accommodate na niya yung hydrogen atoms. Further reaction, that double bond will be broken to become single bond. Okay, and then originally the CH2 here could now accommodate the addition of hydrogen, so it becomes CH3, and that CH2 will then become that CH will then become CH2 because of the addition of another hydrogen atom. Okay, so for hydrogenation of an alkyne, always bear in mind that it needs two molecules of this reactant hydrogen so that the alkyne could become an alkene and then further become an alkene. Okay. Same is true for halogenation. Okay, so halogenation, instead of hydrogen, we are adding halogen. And always bear in mind, halogens are diatomic in the form of bromine, chlorine. So chlorine, iodine, so fluorine. These are diatomic elements. Okay, so still the triple bond will be broken to become single bond, and once it became double bond, there's now the formation of new bond. So dito ma-accommodate yung addition of the halogens, and that would become an alkene pa rin. However, this is now a dihalogenated alkene. For the reaction, it needs another molecule of that halogen, and that double bond will now be broken and turning to become single bond. So originally, these are the two halogens previously added in the first reaction, but with the breaking of that double bond turning to become single bond, it could now accommodate another addition of these molecules to this site of reaction. Okay, so after the complete halogenation of an alkyne, it will now have a tetrahalogenated alkene. Okay, so in the second reaction, we only have a dihalogenated alkene. However, in the last reaction, we have a tetrahalogenated alkene in the form of 1,1,2,2 tetrachloropropane. The tetra indicates that there are 4 halogens being attached to this parent chain. Okay, next would be hydrohalogenation of an alkyne, particularly a propyne. So still, mechanism is the triple bond will be broken to become single bond, and with that, the atoms of the reactant could now be added to the site of reaction. But we have to follow the Markovnikov's rule, wherein it states that the hydrogen of that reactant to be added to the alkyne, okay, will be added to the carbon atom that bears most of the hydrogen. So pupunta daw yung hydrogen ng reactant na to dun sa carbon atom na may triple bond na may pinakamadaming hydrogen. So therefore, this hydrogen will go with the CH. Okay, that's why we have it here. And the chlorine will go to the second carbon atom that bears the triple bond. Okay, so the first reaction will now produce a 2-chloropropene or a halogenated alkene. Okay, second reaction with the hydrogen chloride will now make the double bond to become single bond, and still addition of this HCl will happen to this site of reaction. Okay, but we don't have anymore the triple bond or the double bond. Rather, we have single bond. And at the end of the reaction, we are now having a dihalogenated alkane in the form of 2,2-dichloropropane. Okay. Also, alkynes are combustible, so do not forget that during combustion reaction, um, they are producing carbon dioxide. So if we have alkynes, so CN H2N minus 4. Okay, sorry, CnH2n minus 2. Okay, minus 2 plus, if this is a combustion reaction with oxygen, so always the product would be water and carbon dioxide for a complete combustion reaction.